Hello everybody. Well, I'm sorry I'm not there to help you out, answer any questions that you have on Section 2-1 or teach you Section 2-2. But here's what I do have going on today. I have a skill check written for you on this PowerPoint. If you'd like to try it, what you can do is pause the video on that slide, and then on the very next slide, I have the answers for you. That way you can make sure that you're pretty good on domain and range. What I do need to do with you today is I need to cover Section 2-2 over quadratics. There are some word problems, so don't be scared. And I'm going to ask you to do some things without the graphing part of your graphing calculator. So don't be scared of that either. But I need to make sure that you know how to find the vertex of a quadratic. Got to make sure you know how to find the x-intercepts, aka factoring. And I need to make sure you know how to find the y-intercept when x equals 0. And then we'll talk about a few applications. But there's the skill check. Like I said, you could pause the video and work the skill check. I got you stating the domain and the range of each of the following, just the domain on number 5. And then if you'd like to see the answers to that, you could pause the video on that. But I'll scroll right through that. Let me get to the main lesson of Section 2-2. Section 2-2 deals with quadratics. Remember, quadratic, aka parabola. The general form of a quadratic is ax squared plus bx plus c. And we can't allow a to be 0, because if a is equal to 0, then it's a line. Just some facts about the quadratic. Every quadratic has a line of symmetry and a vertex. Whether it opens up or opens down, it has that imaginary line that goes right down the middle that allows us to fold that over. The a value tells you a few things about the graph of the parabola. If a is greater than 0, aka positive, I know it's going to open up. And if a is less than 0, negative, we know it opens down. Things that we've already talked about this year. Here's the part that we haven't used this year, and I don't know if you know it from FST days. The vertex of a parabola can be found by this formula. The opposite of b over 2a, that's my x-coordinate. To obtain my y-coordinate, I'm going to sub that back into my equation. We'll practice that a few times here in a little bit. We'll use that when we talk about the maximum and minimum of a graph. The x-intercepts, if any, can be found by the quadratic formula or by factoring. There's the F word again. The y-intercept can be found by letting x equal 0. We'll practice all of that on the next few problems. I've only got us graphing a couple of the quadratics because I think overall it'll be pretty easy for you. But don't cheat me. Don't use your graphing calculator part. I'd like to graph this quadratic without your calculator. So here goes. I got f of x equal x squared minus 6x plus 8. We need the vertex first. To get the x-coordinate of the vertex, I'm going to go the opposite of b over 2a, which is going to yield me the opposite of negative 6, which is 6, over 2 times my a value, a is 1, times 2 is 2. So I know my vertex, my x-coordinate is 3. To obtain my y value, I'm going to plug 3 into my formula. So I'm going to go 3 squared minus 6 times 3 plus 8. And when I did that, guys, I got negative 1. So I know my vertex is at 3, negative 1. So if I come over to my graph, I can go over 3 and down 1. Boom. There's my vertex. Well, we know that's not enough information to graph the quadratic. So now I'm going to figure out any x-intercepts. To figure out any x-intercepts, I'm going to set x squared minus 6x plus 8 equal to 0. You could use the quadratic formula on your calculator. I'm going to take this away. So let's factor this into x and an x. Two numbers that multiply to be 8 that we can make add up to be negative 6. Looks like negative 4 and positive 2. If I set both of those equal to 0, I got x to be 4 as one of my x-intercepts and x to be 2. So as ordered pairs, I got 40 and 20. So let me come over here real fast. Let me get 40 right there and 20 right there. That's enough to graph the parabola because I got the vertex and 2 points. I'm going to go ahead and also add in the y-intercept. To find the y-intercept, simply let x be 0. If you let x be 0, I'm going to have 0 squared minus 6 times 0 plus 8. I'm going to get that constant 8. So to make my parabola even better, I got 0, 8. And then while I'm here, guys, remember we mentioned that line of symmetry. It's going to be right through there. Well, 3 units from my line of symmetry is a point at 8, so 3 units this side is also going to be another point. Let me connect my dots for this parabola, and there I got a very accurate graph of that. It has a minimum at 3, -1, and it opens upwards. Here's your next one. We'll graph this without your calculator again. So it's going to look like this. To get my vertex, I need to use the opposite of b over 2a, which tells me I got positive 8 over 2 times 2 is 4. So it tells me my x-coordinate is 2. My x-coordinate's 2. And when I ran 2 through my original equation here, 2 times 2 squared minus 8 times 2 plus 6, I got -2. So what do I got so far? I know at 2, -2, I've got my vertex. Something else I know, it's going to be opening up. Let's go ahead and get your x-intercepts. So I need to take 2x squared minus 8x plus 6, and I need to set that equal to 0. I could try to factor it from there, but I'm going to divide everything by 2, because I notice 2 goes into everything, and I'm going to do it to both sides, so that's okay. So I'm going to get x squared minus 4x plus 3 equal to 0. Now I'm going to factor that into x minus 3 and x minus 1 equals 0. So when I go get my 2 x-intercepts, one of them is going to occur at 3. The other one's going to happen at 1. So as ordered pairs, I got 3, 0 and 1, 0. So let me go over here now, 3, 0 and 1, 0. I technically have enough to graph this. But let me also go get my y-intercept, just so I can be more accurate. So I'm going to let x be 0. If I let x be 0, I get 6 as my y-intercept. So 1, 2, 3, 4, 5, 6. And then because of symmetry, I know there's another point right there. So when I graph this, there I got it. So there's what we got so far. I even tossed one on there to let you use your calculator, with your calculator. I'm not going to spend any time on this one, guys, because I got all the faith in the world that you could type that into your graphing calculator, go second, calculate a minimum, and get the vertex to be at 1/3 and -4.16 repeating. I have all the confidence that you can go second, calculate a 0, and get my intercepts to be at -1 1/3, 0, and at 2, 0. And when x is 0, y is -4. And then we could graph it. So I'm not going to spend much time on that because you're as good, if not better, with the graphing calculator than I am. But I would like to get to some word problems. Okay. Let me show you what we got on this. Don't be scared of the word problems because hidden in there is a formula somewhere. If there's not, we got to go get our own. So it says, an agency sells tickets for an opera Based on the previous experience, this agency has determined that the profit they can make on selling X tickets is given by the function P of X equal 12X minus 0.1X squared. What's the maximum profit they can expect to make, and how many tickets do they have to sell in order to earn this maximum profit? Well, here's all we're going to do. My profit equation, which they're giving me, is 12X minus 0.1X squared. And they're asking you to maximize the profit. So think about this. This thing would be a parabola opening downward. So it's going to have a maximum. To get the x coordinate of that maximum, I'm going to go the opposite of b, which will be negative 12, over 2 times negative 0.1. So I really have negative 12 over 0.2 negative. So if you run that through your brain or your calculator, you're going to get that they need to sell 60 tickets to maximize their profit. And then the second part said, and then what would be that maximum profit? What's the maximum profit? Well, we know that we need to sell 60 tickets, so I need to find P of 60. So I'm going to go 12 times 60 minus 0.1 times 60 squared. So we're going to have to sell them at, if I ran all this through right, we're going to make 360 bucks. So since it's opera, I don't know if that's really worth it. Here goes my next example. It says, assume that a company knows that the cost function to produce X items is given by C of X equal 5X squared plus 800X dollars. It also knows that the revenue from X items is given by the revenue function R of X equal 1000X plus 200. Find the maximum profit they can expect and how many of these items they have to produce and sell to make this maximum profit. Remember from chapter 1 that our profit equation is our revenue equation minus our cost equation. So let's go get our profit equation. Our profit equation is going to be my revenue, which is 1000X plus 200, minus my cost equation. So I'm going to have minus 5X squared minus 800X. I distributed that negative 1 through the cost. And then when I simplify this, I'm going to get negative 5X squared. 1000X and 800X negative is 200X. And I'm going to have plus 200. Is everything looking good there? Yep, plus 200. And then now to bring it home, we know that this thing's a parabola opening down. So I need to find my vertex, so it's going to be the opposite of B, so negative 200 over 2 times negative 5, which will be negative 10. So it tells me I need to sell 20 units. To get how much profit you would get, I'm going to find P of 20. And then we'd run that through a calculator. But notice, guys, the main thing I want to show you here, the opposite of B over 2A gives us the number of units that we need to sell, that we need to produce. The key thing on this one is I needed to come up with a profit equation from what they gave me. So that's what we got so far. If you would, flip to the back side. Just another one, just make sure you're good with the formulas and everything. It says a deli owner has found that his revenue from producing X pounds of vegetable cream, doesn't sound very good, is given by R of X equal negative X squared plus 30X, while the cost in dollars is given by 5X plus 100. Find the minimum break-even quantity. Just make sure you know what we're working with here. Remember, break-even quantity, that happens when my revenue is equal to my cost. My revenue is equal to my cost. So when I do that, I'm going to have negative x squared plus 30x equal 5x plus 100. Now we need to solve this. Since there's a squared involved, I would like for it to be positive, so I'm going to move it over to the right. So I'm going to have x squared. I'm going to subtract 30x over there, minus 25x plus 100 equals 0. Well, I need to figure out when that's equal to 0, so I'm going to try to factor it. So I have an x and an x. I need two numbers that multiply to be 100 that you can make add up to be negative 25. So I'm going to use negative 20 and negative 5. So it looks like we're going to break even 2 times. Whenever x equal 20 and whenever x equal 5. So when I sell 20 pounds, I broke even. And when I sell 5 pounds of this vegetable cream, I break even. And here's how come. This is a parabola opening downwards. So when I look at this, I'm going to break even there and there, but up in here is going to be my main profit. But that takes care of part A. My break-even points are at 5 and 20. Now it says find the maximum revenue. So the only thing that you want to work with is the revenue equation, which is negative x squared plus 30x. We want to maximize it. How do we know it's going to be a maximum? This is a parabola opening down. So I'm going to go the opposite of B over 2 times A. This tells me my maximum revenue is going to occur at 15 pounds of that. To figure out how much the maximum revenue is, I'm going to plug 15 back into that formula. And I did that already, and I got that the maximum revenue is $225. For part C, it says find the maximum profit. Well, I need a profit equation then, which is going to be my revenue, which is negative x squared plus 30x, minus my cost, which will be minus 5x minus 100. If I simplify that, as I'm running out of room, I've got negative x squared plus 25x minus 100. You'll know to do the opposite of B over 2A whenever it says maximum and you're dealing with a quadratic. So to bring that home, I'm going to take the opposite of B, negative 25, over negative 2, and I'm going to maximize my profit when I sell 12.5 pounds of the cream cheese. To figure out what that profit would be, I'm going to plug this back in. And when I did that, guys, I got $56.25. So those are what we got so far. And I know what you're thinking. You're thinking, those are way too easy. So, of course, then we'll make them a little bit tougher then. So here goes. Hey, and I need to change this one, especially for our football players. I thought I changed it on here, but I opened the wrong one. So let me, in black ink, let me get rid of Coach Cornelson. And let me put Coach Black. So let me show you what we got so far. It says when Coach Black charges $600 for a seminar on coaching football, it attracts 1,000 people. For each $20 decrease in the fee, an additional 100 people will attend. His coaching staff is wondering how much to charge to maximize their revenue. So here's their thinking right now. I have a price, and I have the number that will attend, which gives me how much revenue we're bringing in. So let's look at what they got so far. They said when we charge $600, we can get 1,000 people to show up. So our revenue is an impressive $60,000. Then it says for each $20 decrease in the price. So if I drop my price to $580, an additional 100 people is going to show up. When I ran that through, I had $638,000. So that also means that this one should have been $600,000. So they said, man, we made some more money. Let's do it again. So they're going to drop the price another $20, gaining another 100 people. And when I ran that through, I had $672,000. This is a big-time clinic. So let's get greedy. At 540, they can get 1,300 people. Well, that came out to be $702,000 in revenue. Well, our job, guys, is we got to figure out what makes it the best. What's going to make it the best. So here's what we got to do. We're trying to maximize our revenue. And we know from Chapter 1 that our revenue is the price that we're going to charge times the number that we're going to sell. So think about the price. Let me come up with the price. The price that I'm looking at right now is $600. But notice what we're doing to the price. I'm subtracting $20 away from it. So my price is going to be 600 minus 20x. If I drop it once, I'm at 580. If I drop it twice, I'm at 560. The number of people or tickets that I'm going to sell in this case then is, notice what happens. Originally, I started at 1,000. But notice that every time I drop the price $20, I gain 100 people. So the people is going to be 1,000 plus 100x. So peek at what I've done there for a second. X represents the number of times. X is doing double duty here. X tells you the number of times that you drop the price, but it also tells you the number of times that you increase 100 people. So now here goes. Remember, my revenue is my price times the number of people. So that's what I'm going to do. I'm going to take my price, which is 600 minus 2x, 20x that is, times the number of people, 1,000 plus 100x. So there's where I am so far. That's going to give me my revenue. Here's what we get to do with this. We get to FOIL all of this out. And when I FOILed all of that out, guys, I got negative 2,000x squared plus 40,000x plus 600,000. Now you got to think about what we're trying to do. We're trying to maximize this revenue. If you think about this, this is a parabola opening down. So a parabola opening down has a vertex. To get that vertex, I want to take the opposite of b, so negative 40,000 over twice my a value, which will be negative 4,000. So I'm going to get x to be 10. Here's what that 10 means. It doesn't mean I'm going to sell my tickets for $10. It doesn't mean I'm going to allow 10 people to come in. It means I'm going to drop the price 10 times. So I need to plug a 10 right there and right there. So here's going to be my maximum revenue. The price I'm going to charge is 600 minus 20 times 10. So the price I'm going to charge is 400 bucks. The number of people, I'm going to plug a 10 right there. The number of people will be 2,000. But the bottom line there is, we had to come up with a revenue equation. So I need to figure out the price I'm going to charge and the number of people that will attend. I've got another one very similar to it coming up. So there's where we're at so far. So here we go. Here's my next one. Mr. Lycum, promoter for the rock band Metallica, you got to give me that one, knows that he can sell 1,000 tickets at $50 each. He will not sell tickets for less than 50 bucks. He knows from past experience that for every dollar increase in ticket price above 50, they will sell 10 fewer tickets. Find the maximum revenue. Well, here we go again. I need to maximize my revenue. And remember, your revenue is the price you're going to charge times the number of tickets, the number of people, whatever we're dealing with. So here goes. Read back through there and let's figure out the price. We know that we sell the tickets at 50 bucks, and we know Mr. Lycum will not sell them for less than 50 bucks. So I know my price starts at 50. And it says that for every dollar increase in ticket price, they will sell 10 fewer tickets. So every time I add $1, so 50 plus 1x, my number of tickets that I'm going to sell decreases. So my number of tickets is going to be 1,000, and I'm losing 10 tickets every time we raise the price. So my price is going to be 50 plus 1x. My tickets will be 1,000 minus 10x. That makes my revenue then, my price, which is 50 plus 1x, times the number of tickets, 1,000 minus 10x. You know where we're going from here. I need to FOIL this thing out. So I would get 50,000 minus 500x plus 1,000x minus 10x squared. And if I simplify this, I've got negative 10x squared plus 500x plus 50,000. Well, we want to maximize it, and it's a parabola opening down, so we know it has a vertex. So get the vertex, the opposite of b, over 2 times a, negative 20. So I'm going to get x to be 25. Please don't think it means $25. It means I need to raise the price 25 times. It means I'm going to sell 10 times 25 fewer tickets. So my price that Mr. Lycum is going to charge is going to be 50 plus 1 times 25. We're going to sell tickets for 75 bucks. That's going to be my price. The number of tickets we're going to sell, I'm going to plug in 25. 1,000 minus 10 times 25, we're going to sell 750 tickets. And then to get my revenue, 75 times 750, my revenue is going to be $56,250. So there's what we got so far. Last but not least, I just tossed one of these in because in your book assignment there's one of these. It says Farmer Brooks has 450 feet of fencing to enclose a rectangular region adjacent to a river. Here's what we got so far. Here's my river. Farmer Brooks is making a pasture that's rectangular. So we're going to assume 90-degree angle since the word rectangular was tossed in there. The side on the river will not need any fencing. What dimensions will maximize the area that Farmer Brooks could have? Well, I want to maximize my area, so I just got to start figuring out what I need. I know that if it's rectangular, these two sides are the same. I know I started with 450 feet of fencing. If I use X here and X here, the amount of fencing for here will be 450 minus 2X. So there's my setup. I want to maximize the area. Well, the area of this rectangular figure will be my length, 450 minus 2X, times my width. So my area is going to be 450x minus 2x squared. Now we want to maximize it. Well, look at what we got once again. A parabola. So let's find the vertex. The opposite of B over 2 times A, negative 4. It tells me that x is going to be, 250, 112.5. So what do I know so far? I know my width needs to be 112.5 feet. The length then, I'm going to plug 112.5 right there and get 225 feet. The area then would be length times width, which would be 112.5 times 225, 25,312.5 square feet. So it's all about getting the equation of a quadratic and then finding the vertex of it. Hey, assignment-wise, looks like I have you in the book. It looks like a lot more than there really is. 3 through 8 and 21 through 26 are matching. Match the quadratic, match what we have. 14 and 20 are graphs. The rest are application problems. On number 59, the graph that data like we did in section 1-3, stat, enter it into L1 and L2, and then decide if it's linear, number 4, or quadratic. And let your calculator do the work for you there. Hopefully you think the lesson's pretty easy. Good luck!